All right, let's get going. We got the sine 45, cosine 45, tangent 45. I wrote those right here to help us remember. And in case you're wondering about those 30, 60, 90s, oh yeah, I got those ready right here. All right, so let's get into these first problems. Let's see what's going on. So, you in general, you want to choose an angle, and it's kind of silly in 45, 45, 90 to choose an angle because these two are both 45, but just do it to be safe, especially as you're learning and getting these really solid. Later you can use shortcuts. So x is 45, this angle is 45. Go across is the opposite side. Across from the 90 down here is the hypotenuse. Opposite and hypotenuse is a sine. Sine 45 equals 7 over x. We replace the sine 45 with its value of square root 2 over 2. And that's right here. We cross multiply, and when you cross multiply and you do a little division in the last step, you'll get x is equal to a number times the square root, and that is its simplest form. In number 4, they're giving you these legs are 5 square root 2, and the hypotenuse they're asking for is x. X will be a whole number here, actually. A hint is that the square root of 4 is 2. Of course you know that, but hey, that's something that comes out in the work, and that's what I did. This one, number 5, x is a leg. The 3 square root 2 is the hypotenuse, and x comes out to be a whole number this time again. This time, the key work that made that happen was square root 2 divided by 2 canceling in the work. Please make sure you're showing your work. Next up, we have these problems, and you really have to label opposite, adjacent, hypotenuse. To find x, we have to realize we're using the opposite and the adjacent, which is a tangent. And so the tangent of 30 will equal opposite over adjacent. And then we look up what is the tangent of 30. And the tangent of 30, we can see, is square root 3 over 3. So we come back here, and the square root 3 over 3 replaces tangent 30 equals 9 over x, and we now just cross multiply, and x should come out to be a number times the square root of another number, and that's your answer for x. And a hint here is that when you do y will be a whole number. Just in case you need some tips on finding y, hopefully you'll realize now you need to use the opposite and the hypotenuse, which is a sine. So you'll say the sine of 30, because that's the angle we're using. The sine of 30 will equal opposite over hypotenuse. And then we look up what is the sine of 30, and we remember, oh, the sine of 30, that's 1/2 right there. And so the 1/2 replaces sine of 30, and you'll get 9 over y, and that's why y is a whole number. In number 9, both x and y both come out to be whole numbers. So hopefully that makes that problem kind of easy. You could do the whole sine and cosine and tangent stuff to find it. Very similar to this one, except you're using 60. You could even use this angle 30 if you really wanted to. Both ways work. In number 10, it's a little trickier because the hypotenuse has a square root 3 on it. So when you go and do all your cross multiplying work, like how over here we were supposed to cross multiply, when we do that over here, you'll get that y is a number times the square root of a number, and you'll actually get that x comes out to be 18, and I'd really like to see your work show that. On number 13 here, continuing, this is very similar. It's another 30, 60, 90. And in this case, y should come out to be a number divided by 2, and like a fraction. And x should, like a fraction, of course, it's a fraction. And x should be a number times the square root of 3 divided, I'll say also by 2. So it's actually pretty easy in the end. Make sure you're showing your work. Don't just fill in these boxes. I'm just giving you help so you know what the answer looks like, and hopefully you can check your work. I super hope you realize that 14 is a 45, 45, 90. So you'd say, okay, you can use m and n are going to be the same, right? And hopefully you're realizing, oh, it's easy. I could say sine of 45 and just choose either 45. It doesn't matter. This would be the opposite hypotenuse, and this opposite over hypotenuse would be n over square root 6. And now we solve. Remember, sine 45 is square root 2 over 2, which we had way, which we had way up here at the top of the document. And you know, when you finish this and you do your cross multiplying coming up right now, I really hope you realize it'll be 2n equals the square root. And what goes in here is because this square root 2 multiplies with this square root 6. Of course, we've been learning that you can multiply those two values together and get a larger number inside the square root. So make sure you got that. Your final answer should be that n equals the square root of 3. Please make sure you're showing your work for how you got there. For number 15, you know, you can do a sine and or cosine and tangent of 30 or the 60, but you might be realizing there's a shortcut here. Remember how this came from the larger equilateral triangle where we called this side x and we called this side 2x, and then it came out to be when we did the Pythagorean theorem that this was x squared root 3. Well, you might start to realize there's some shortcuts on all these problems. So you can show your work this way, or if it's like this, you could say that this smallest side here is just, you know, because that's 2x and that's x, this is just half of this long hypotenuse, right? Because it was a 36, it was an equilateral that was sliced in half. So, of course, in that case, p will just equal 12 because that's half of 24. And then since this is 12, q will have to be 12 times the square root of 3. And it's nice to start to see that shortcut. Now be careful. Like, you can't just apply those shortcuts randomly, because on this type of problem, you really got to show your work working downward. Continuing, 16 is actually really easy. R is super easy, and S, make sure you're showing your work one way or another, but S will be 9 times the square root of 3. Show your work. I'm just showing you the answer to check your work. On this one, you have to first realize that this obviously drops down, and then that this piece right here is 3. Now U is this entire side. So what do? Oh, the next piece is, oh, this is 4, so this is 4. So what does that mean? That this piece right here is 4. So then U is super easy, right, because it's the whole side. And then U is too easy now, because I've shown you. And T is a number times a square root. And the number in the square root is not a 3, because it's a 45, 45, 90, right? So remember how to do that. Show the work. 18. What's going on here? Oh, it's actually easy, you know. This, if you really kind of get into this, you could say, oh, look, this is the shortcut again, where if we look at this triangle, the hypotenuse is like the 2x, and this littlest side is like the x, and then this side is x squared root 3. When that medium side that is across from the 60 has a square root 3 on it, then the shortcut would be to realize that the x, just the x, like the short side piece, oh, that had to be 9. So E could be 9, and then F, well, what did we learn? Oh yeah, that's just double, so that's 18. So that's a shortcut way to do that. Now that F is 18, G is now part of a 45, 45, 90, where you'd have to show your work, and G should come out to be kind of similar to T, right? Actually, so it'll be a number times a square root. That's as simplified as you can make it. 23. Reminder, show your work. G, F, both answers have square roots. Both answers have square roots. We'll leave it there. All right, 24. 24 starts to get interesting now. What are we looking at? First, realize a straight line adds to 180. This will be 30. You can label opposite from the 30, adjacent. Of course, we're using the 30-degree angle, opposite, and of course, this is hypotenuse. Now, usually square root 2's appear in 30, 60, 90s a lot. I mean, square root 2's appear in 45, 45, 90s. But of course, they could just be the starting side. Let's work with it. Let's see what happens. So, what we do, let's say we want to find x. So, hey, opposite, hypotenuse, 30. We're using the 30, so that would be a sine of 30 equals x over 4 times the square root of 2. What's the sine of 30? The sine of 30, reminder, oh, that 1/2 again. So 1/2 equals x 4 square root 2 cross multiply, and we're going to get 4 square root 2. 4 square root 2 equals 2x. Divide both sides by 2. X equals, this eliminates, and here these two plain numbers can divide together and you'll get 2 square root 2. That is the value of x. Now to find to find y, you have to use cosine. So the cosine of 30 is going to be the adjacent over the hypotenuse, and you got to look up what is the cosine of 30. That is square root 3 over 2. And then here, remember how this works. When you cross multiply, of course you'll get 2y, but you'll get 4 times the square root of 3 times 2 together makes 6. Now finishing is super easy. Make sure you finish and find y. Yeah, don't forget to finish and find y. Y equals, right? That's going to be your final answer here, like x. Over here now, it's really important to not get intimidated by a little bit more complex shape, right? You can almost like ignore this part right here. That's 30. That's 90, of course, because it's 90 on the other side, and so that's 60 up here. And just label your triangle. X is super easy if you just use like a sine of 30. And y, once you find x, you're going to use that to find y. And so then you'll ignore this part over here, and you'll just use another little 60, the 30s here, a 30, 60, 90. And y will come out to, for y, you'll get a square root in the denominator, and then once you remove that, your final answer will look like a number times the square root divided by a number, because these two numbers will not simplify. I've been waiting to discuss these problems. They're great, you know, and it's kind of tedious in a way, though, also because each one of these columns is like a new problem, and they're saying, look, if A equals 7, then what's B and C? Now, what if B equals 11 right here? Then what are A and C, right? So you have to use the patterns. Now, the 45, 45, 90 way easier than 30, 60, 90 because A and B are going to be the same. So if that's 7, then that's 7. If that's 11, that's 11, right? Because these two sides are the same. So that makes this whole table super easy. In this one, like this one right here, will just be square root 5. And I'll tell you, this will be the square root of a bigger number. For these ones, your answer will be in a number times the square root. And then for these ones, it'll be just actually a plain number. And why I've been wanting to talk about this is, you know, when you have a 45, 45, 90, you can use that the sine of 45 equals square root 2 over 2, and so does the cosine, and the tangent equals 1. But remember, this came from this work, right? And so if you know that this piece is 7, then a shortcut, of course this is 7, but the shortcut is that if you know that this is x is 7, then this will be 7 square root 2. And so that kind of makes these super easy. Warning though, you know, if you do this trick of x and x and x square root 2, you're kind of playing with fire. Now over here, remember the trick was that this came from x, x square root 3, and 2x. And you can use sine, cosine, tangent. However, when you have a 30, a 60, a 90, there is this shortcut. Let me see what I want to tell you here. Here are some hints, and this number actually comes out to be 27. Make sure you're showing your work for that. And this number should be 4 square root 3. Hopefully this gives you a good sensation that you're on the right track and you can check your work. So this problem is interesting too, and I really hope you realize that your skills you just used all right here, are really the same story here, except it's more in a visual diagram. Now, also what's super interesting about this problem is you might think, oh, hey, this is a 30, 60, 90, this triangle right here, and that also, of course, this is a 30, 60, 90, this triangle right here, and there's just two that are touching. But actually, there's a third one. The overall one is also a 30, 60, 90, and so you can use some really cool shortcuts here to realize, oh yeah, the whole big one is also a 30, 60, 90. So a equals 10 square root 3, and that's the hypotenuse, and it's just given. And if that's your 60, right, then this side would be the opposite of the 60, and then this side, this little x would be the adjacent. And you could do something like, let's say you want to find x, adjacent over hypotenuse is cosine. So the cosine of 60 equals x over 10 square root 3. And the cosine of 60 is 1/2, right? And so 1/2 equals x over 10 square root 3. Cross multiply, divide by 2. You should just show your work a little bit and get x equals 5 square root 3. Once you know that x is 5 square root 3, okay, cool. You want to find y next. Now, to find y, though, you have to find the opposite side. And that's CE, actually. So you want to find CE. If I was a student, I would probably label that as a variable just to make it easy. CE is this purple line right here. And what do we want to call that? Let's call this opposite side CE from the 60 opposite, I don't know, Z. And so you're going to want to find Z, and then once you find Z, then you can work on this triangle and you can find Y. That intermediate piece Z will be a whole number actually, and then Y will have the format of a number times a square root. Please make sure you're showing your work. I like this problem. It's the same diagram, but now they're just giving you something different. Now they're saying x is 7 square root 3, and they want you to find all these things. So this is 7, right here, of course, x. That's better. And all right, what will we do? Well, find a. A will equal a number times the square root of 3. Show your work. CE, this piece again that I called Z, so we'll say CE equals Z, and Z should come out to be a whole number. And they want us to find Y, and Y should come out to be a number times the square root of 3. And they also want us to find B, and that means, well, of course, with Y and B, this is a 30, 60, 90. And B should be, well, B is going to be double whatever Z is. That's a shortcut. So that'll be another whole number. Please make sure you're showing your work one way or another. Okay, I'm going to stop saying show your work. Show your work on all problems. Not again. Not going to say that. This is a great problem. You got to find X, Y, and Z and then find the perimeter. So when you do all the work, what's going to happen is you're going to get a plain number. You're going to get actually 4 plain numbers, plus you're going to get a number times the square root of 3, plus a number times the square root of 2. And actually, just a little hint I'll give you is that this number in front of the square root of 3 and the square root of 2 are the same number. So when you solve it and you add up everything, these 4 numbers will combine, and you should get 24 plus a number times the square root of 3 plus a number times the square root of 2. And then that's the same number right here, right? It's just you have to keep all 3 of these things separate. So because it's like as a single number, this is like one type of thing. Like you got so many square root 3s and you got so many square root 2s, and they stay separate. These are great. let me try to help you. Let's read it and do it. The length of an altitude, you know, the altitude means like you drop a line and it's like the height. The length of an altitude of an equilateral triangle is 12 feet. So what are they saying? You got an equilateral triangle, which means all sides are the same, 60, 60, and that angle up here is 60. And the altitude is when you drop a line down to basically at a perpendicular angle at the bottom, at a 90-degree angle, so the line is perpendicular to one side. And that's the altitude. That's the altitude that I did in green. And it says the altitude of an equilateral triangle is 12. So this piece is 12. Find the length of one side. So what they're really just asking you to do is to then find the hypotenuse here. And so we'll call that capital H for the hypotenuse, which is also just one side of the triangle. H is one side. And in the end, your work should come out to be a number times the square root of 3. And please show your work. These are all really good, right? Let's take a look at this next one. What's it saying? The perimeter of an equilateral triangle is 45 centimeters. So all these three sides added up, the perimeter is 45. I hope you immediately realize these are each 15, right? So that's a key thing because all sides are the same. Find the length of the altitude. So they want this green line right here, right? So here, oh, whoops, that's not a green line. They want that same green line, that altitude. So we'll call that A for the altitude for one side, and hope you realize this is the hypotenuse. This is 60. You can do a traditional 30, 60, 90 work, and you should get that in the end, A equals a number times a square root over another number, because these two numbers will not divide. Oh, these problems are so much fun, you know. Let's read it. Let's get into it. The length of a diagonal of a square. Okay, so the diagonal is 22 times the square root of 2. Find the perimeter. Okay, let's see. We got a square. The diagonal is 22 square root 2. You got to know diagonal means across the square. Find the perimeter. So we're just going to find one side, right? And because it's a square, we're going to multiply by 4, right? So the perimeter is just going to be, 4 times one side. So let's find one side. What's that going to be? Well, you gotta realize in a square, all the angles are 90, so it's a 45, 45, 90, and there's a great jazz station in Los Angeles, 88.1 K Jazz. There's a hint. It's a great radio station. Listen to it all the time. The altitude of an equilateral triangle is 7.4 meters long. Find the perimeter. Oh, here's some similar stuff, right? So here's our equilateral triangle. The altitude, so our green line, is 7.4. And of course this is 60, 60 because all angles are the same. And then this is 30 up here. These are 30. And so you can label opposite adjacent hypotenuse and find one side. So find the hypotenuse, and then the perimeter would be 3 times that hypotenuse, whatever it comes out to be. And the perimeter will be, now on all the problems we're supposed to do simplest radical form, but because they throw this decimal at us, let me just tell you that this final answer should be 8.54. So on this one, let's simplest radical form not implied. And so let's let it slide here and write our final answer as a decimal, and please show your work for how you get that. Number 20. The diagonals of a rectangle are 12. So what they're immediately talking about is we have a rectangle and the diagonals, this whole line is 12. And they say diagonals, so I'm going to draw both of them because it's plural 2. Multiple. They're each 12. So I'm just going to label this 6 and 6 because it's symmetric. They're getting cut in half. Of course, this is 6 as well. Find the perimeter. Okay. Oh, but what else? I kind of jumped around when I read this. The diagonals of a rectangle are 12 inches long and intersect at an angle of 60 degrees. Well, when these diagonals intersect, they're actually, intersecting and creating four angles, right? And of course, because we've learned about vertical angles, these two angles are equal. And we could also say that, like, these two angles right here are equal. So just choose one of them to be 60. And the natural one to choose 60 is, of course, this angle is 60 because it just looks like that's 60. And then if you wanted to think, okay, this angle right here would be 120 because two angles add to 180. And you could do something fancy like say, okay, let's slice this down the middle and create a 90. This will now be 30 because it got split in half. And then this angle would be 60. That's a little unnecessary here because I hope you could be a little creative and say, oh, that's 6, that's 6. So, this will also be 6 because if this is 6 and 6, then the triangle is isosceles. So that means that these two angles are the same. Well, if this is 60 and the three angles add to 180, take away the 60, that means these two have to add to 120, so they're each 60. And that means it's equilateral. And that's how I knew this was 6, is because that's an equilateral triangle. So you didn't have to slice that down the middle. Now, they're asking for the perimeter. So we can do some quick work right now. We can say, okay, look. The perimeter is going to be this piece here, 6. This is, of course, also 6. So the perimeter would be 6 plus 6 plus. Now, what are these sides going to be? Now, the lazy student, I shouldn't say lazy, the student who's maybe a little bit confused or just jumping to the answer too quick. Oh, that's 6. Looks so good. That's 6. So this piece is all right here is 12. So that's 12. So this is 12. Now, that's not the case because you can't just, how do you know that's 6? That's 6. That's not true, right? Because really, this piece is 6. So now we really have to get slicing and dicing. So let's slice and dice. Now that 120 got cut in half, right? So that angle is 60. That's 90. Oh, so this is 30? All right, this is coming together. We have a 30, 60, 90. The hypotenuse, this is 6, right? So we have to find this length here, that green length. That green length is going to have a format once you do the work and you label opposite, adjacent, hypotenuse. That green length is going to have a format of a number times a square root of 3. Now, to find this blue length, which you need for the perimeter, you're going to take this number and you're going to times it by 2. And that number, when you times it by 2, that'll make just that number here bigger and it'll keep the square root of 3 as square root of 3. So the whole blue length will be square root of some number times 3, times the square root of 3. And then, of course, that will be the same deal up here. And so when you're finding the perimeter, it'll be 6 plus that blue length, which is a number times the square root of 3, and then plus the same piece on the top, which is the same number times the square root of 3. When you're finding the final answer, these will, of course, combine to be 12. And then these will combine to be, basically this plus this will just double it, and it'll be a number times the square root of 3. Kind of like combining like terms. Like if you had 100 apples plus 100 apples, you'd have 200 apples. So the square root of 3 maintains. And that should be your final answer. Here on 21, you really have to read this carefully. I hope this work is not distracting. The sum of the squares of the sides, and I crossed out the measures because that word is silly. The sum of the squares of the measures of the sides of a square. Yeah, of course they're talking about, what else do you have about a side? You have the color of a side. I mean, you have the thickness of a side. I mean, not really. You don't even really have the thickness because these are lines, and lines are infinitely thin. Infinitely thin. So, the sum of the squares, the sum means add. Squares just means to square it like that. The sum of the squares of the sides. So, the sum of the squares of the sides of a square. So, the sides of a square, that's like, we'll call that x, each side. The sum of the squares of the sides. So the sum, we add them together, of the squares. Each one of these is a square, right? And it's a square because it's funny because there's two. The square word is implying exponent here, and then here this word square really means the shape, right? Okay, the sum of the squares. So the sum of the squares of the sides. So each side is x. The sum of the squares of the sides. X is the side. Those get squared and then get summed. So each side x gets squared. The sum of the squares of the sides. The sum of the squares of the sides. Those combined together, I hope you've been thinking this whole time is 4x squared. We solve by dividing by 4. That's 64. Square root x equals 8. Once you know that's 8, then it's easy to find the diagonal. You just got to do a 45, 45, 90. And of course it's 45, 45, 90 because this angle is 90. We cut equally into two parts with the diagonal. And the diagonal will have this answer format of a number times a square root. I'm afraid I messed up the recording, but anyway, z will equal a number times the square root, and that number will not be a 3 or a 2. Let's zoom in on this one. BD is 8 square root 3. So that is this line right here is 8 square root 3. The measure of DHB is this angle up here. That angle is 60. Inside, kind of like slicing through this block of cheese. That angle that comes down is 60. Find BH. Well, BH is just this piece. This is disappointing. I'm disappointed in the authors of this problem because it could have been so much better. They could have asked you to find this line, BG. But I seem to be messing up my pause button, but anyway, BD is 8 square root 3. This angle here is 60 because that's DHB, and they want you to find BH, the hypotenuse, and BH will come out to be a whole number. Sorry if this was repeated. I was messing with my pause and I don't want to edit this video. Let's see what's going on here. This is a terrific problem. What was the hypotenuse becomes a leg. Check this out. So they're asking you to find x. So you kind of got to work backwards, right? So this is 4, right? And so you can label it up, or you can use a shortcut that we've been talking about, and you'll find that this piece ends up being 2. This piece ends up being 2 square root 3, and that's just from doing work on a 30, 60, 90. You know, you can label this triangle carefully. This is 30, opposite, adjacent, hypotenuse is 4, and find these sides. Once you find this side, then this is a fresh, you got to see this triangle that I'll highlight in green. This is a fresh 30, 60, 90. And now the hypotenuse is 2 square root 3. What a great question. You know, you really got to see, oh, that's now the hypotenuse. So now you're going to find this side, and then you'll find this side right here. And once you find this side, this is now the hypotenuse for this new triangle that I'll highlight in pink right here. And so then that's a new 30, 60, 90. And you do all that work. And what should x come out to be? This is terrific. Such a great problem. You know, what can I tell you? I'll tell you some more. So this is going to be square root 3, this piece right here. And then this piece actually will come out to be 3. And then this piece, I'm going to stop. And what's quite miraculous is that x actually is 3. X comes out to be 3. And don't just tell me that that's because, and it is true actually, I just realized that we could kind of like say that this is symmetric right here. It's like these two triangles, are they 30, 30, 90, yeah, that's 60. That's 60. And no, wait. Am I doing this right? I need to check. Sorry, I got it now. This is great. Yeah, you know, do all the work. And x comes out to be 9/4. I love it when the answer is a fraction. It's so beautiful because it shows you the process. whatever. Next problem. That's the answer. Last problem. In all honesty, this last problem is actually easier. This 135 was probably the trickiest of all. Whoops, what am I doing? Actually, I kind of want that over there anyway so that I can make it nice. All right. In a regular hexagon, blah, 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 all the points, each side is 12. So immediately, each side of the hexagon, so of the big hexagon has 6 sides, right? These are triangles. So of course they're talking about the big thing. Each side is 12. Oh, and they even label it 12, right? Why am I writing these purple 12s? Find W to Y. Well, that's as simple as finding this side and, just doubling it, because those two pieces are the same. WY is just, whatever this piece is times 2. So let's say draw this separate. That might help. That's 12. And what are these angles? Well, look at how these angles these are all equilateral triangles in here. They're really trying to give you a hint here. So these are all 60s, right? And these are all 60s, and that means that this is 60. This angle up here is 60, and this is 30. And so 30, 60, and you just want to find this piece, and you want to times it by 2. And your answer, because W to Y, like I said, was twice, so your answer should be WY equals some number times the square root of 3. I hope this video has been helpful. Send me a message if you have a question.